Hello everyone. Today I'm going to talk about lesson 10.4, inscribed angles. So our objectives today are to find measures of inscribed angles as well as find measures of angles of inscribed polygons. So let's do a definition here. An inscribed angle has its vertex on the circle and sides that contain chords of a circle. So here we can see that angle QRS fits that bill. Angle QRS is inscribed in circle C. And we know here, again, the sides contain chords of the circle, so the chords that make up a angle are QR and SR. All right. Second definition here, an intercepted arc has its endpoints on the sides of an inscribed angle and is in the interior of the inscribed angle. So here the intercepted arc is arc QS. This is the intercepted arc, and we use our notation here. Arc QS is the intercepted arc. All right. And so let's talk then about these three cases that could happen. Okay, if we have an inscribed angle. Okay. Case 1, center P is on the side of an inscribed angle. So here you can see that the inscribed angle, it includes the center of the circle. So one of the chords is a diameter. That would be. All right, case 2, center P is inside of the angle, and in case 3, center P is in the exterior of the angle. So you can see all three possibilities here we have with inscribed angles. All right. So let's go on to theorem 10.6 here. Theorem 10.6 states, if an angle is inscribed in a circle, then the measure of the angle equals 1/2 the measure of its intercepted arc. So here, if we're talking about angle 1, the measure of angle 1, the measure of this angle is 1/2 the measure of the intercepted arc, which in this case would be arc AB. Measure of. And then, of course, the theorem, it follows that the measure of arc AB is 2 times the measure of angle 1. So you kind of go either direction here. And so example 1 just uses this theorem 10.6. Uses it both ways. So here, part A, we're looking for the measure of angle P. So that's an inscribed angle. So the measure of an inscribed angle, so the measure of the angle P is 1/2 the measure of the intercepted arc. The intercepted arc for angle P would be arc MN. So we can use theorem 10.6, and we should be able to find here angle P because we know arc MN. So measure of angle P is 1/2. Arc MN is 70 degrees. So the measure of angle P is 1/2 of 70, which is, of course, 35 degrees. Right? And then this next one, we want to find the measure of arc PO. So here we're using the arc, but it's the intercepted arc for the inscribed angle, angle N. So we can use that the measure of angle N is equal to 1/2 the measure of, well, what the intercepted arc here is the arc we're looking for, of course, PO. All right, we know angle N, so here we can use that 56. We substitute 56 degrees for angle N is 1/2 of measure of arc PO. So multiply here both sides by 2. Cancels your fraction. 2 times 56, of course, would be 112 degrees is the measure of the arc PO. All right. And so I'll leave these next couple of examples. You use theorem 10.6 here on these next couple of examples. I'd like you guys to go ahead, pause, give them both a shot here. All right, if you tried this one, you probably found, all right, so the picture's a little more complex here, but really we've just got two inscribed angles and we've got two intercepted arcs, and we're going to have to use those very similar to the last problem. I'll kind of try to color code again here so that you can see it maybe a little more clearly. So CF is 1A is asking us to find arc CF. So CF, well, what inscribed angle does CF, well, what's that the intercepted arc for us? So that's the intercepted arc for angle D. Angle D intercepts arc CF. So we use theorem 10.6. We know 1/2 the measure of the intercepted arc is equal to the measure of the inscribed angle, which is angle D. And so we can just plug in angle D, of course, is 40 equals 1/2 the measure of CF, which is what we are looking for. So again, multiply both sides by 2. 2 times 40 is 80 degrees. So there we have found the measure of arc CF. All right. And now here we are looking for angle C. So angle C is, we're talking about this angle, and the intercepted arc is arc DE. You guys, if you tried this and you just couldn't visualize it, well, now use that red picture and you guys go ahead and find angle C, so you guys can do that. And you should find, if you do everything correctly, that the measure of angle C is 49 degrees. All right. Let's continue. All right. Theorem 10.7. All right. It states that if two inscribed angles of a circle intercept the same arc or congruent arcs, then the angles are congruent. So angle A and angle C both intercept the same arc. So you can see here angle C and angle B, they both intercept arc AD. So if they intercept the same or congruent arcs, then the angles must be congruent. Right? So, well, how do we use that? Yeah, it's around here. So how do we use theorem 10.7? This next example, great example of that. So here, we want to find the measure of angle T. Right? Well, so clearly here, angle T intercepts arc SB. Angle U intercepts arc SB. So they intercept the same arc. So angle T, the measure of angle T, must be equal to the measure of angle U. These are congruent angles. So that gives us this equation, 3x minus 5 equals 2x plus 15. Thanks. So if we solve this equation, we should know what x is and then be able to plug in, and again, we're looking for angle T. So let's subtract 2x. So x minus 5 equals 15. Add 5. We get that x is 20. All right. And so now we got to plug into angle T. So the measure of angle T is 3 times x is 20 minus 5. 60 minus 5. Angle T is 55 degrees. All right. And so that's how you use theorem 10.7 there. Another theorem we want to use here, and this is going to help us with our angles of inscribed polygons objective here. Right? An inscribed angle of a triangle intercepts a diameter or a semicircle if and only if the angle is right. So here we've got triangle FGH. Okay. Triangle FGH. This angle G, it intercepts a diameter. Okay? It intercepts a diameter, or what we call a semicircle. So that means that angle G, that angle that intercepts the diameter or semicircle, must be a 90-degree angle. All right. So that's how we use theorem 10.8. let's use this example. Example 4, we're going to use theorem 10a. And so to find angle F. All right, so we know this triangle. This triangle must be a right triangle because angle G intersects a diameter at JH, excuse me. So we know that angle G must be 90 degrees. Again, we also know, this is just from semester 1, that these three angles, angle F, measure of angle F, we know the three angles should all add up to 180 degrees. That's just the sum of the angles of the triangle, the interior angles of the triangle. All three of these angles should add to 180, so we can use that to find angle F. So substitution here, 4x plus 2, that's angle F, plus we know angle G is 90 degrees, plus angle H is 9x minus 3. All of this should equal 180. So combine like terms, 4x plus 9x, 13x, 2 plus 90, 92 minus 3, so minus, plus 89 equals 180. Subtract 89 from both sides. 13x is equal to 91, and x would be equal to 91 divided by 13. And so x is equal to 7. All right. Of course, we didn't need to find x. It asked us to find angle F, so we just got to plug in x. 4 times substitute 7 for x. Plus 2, 4 times 7, that's 28. Plus 2, so angle F is 30 degrees. All right. Last theorem we've got here, theorem 10.9. Let's take a look here. Theorem 10.9. If a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. To be supplementary means that they would add to 180. So if a quadrilateral is inscribed in a circle, that means all of the vertices are inscribed angles, then these the opposite angles would be supplementary. Okay, so K and M would be supplementary. So measure angle K plus measure angle M would be supplementary. They would add to 180. And measure angle L plus measure angle N would add to 180. And so this is if we have a quadrilateral that's inscribed. Quadrilateral four-sided figure here. All right, so quadrilateral WXYZ is inscribed in circle V. Find the measure of angle X and the measure of angle Y. So to find X, well, X is opposite of Z, so we can use that measure of angle X plus measure of angle Z, which is 60. Those two angles, those opposite angles, should be supplementary. So we can find here that the measure of angle X would be 180 minus 60, 120 degrees. And then we can use that angle W here, angle W and angle Y. Those are opposite angles. So angle W and angle Y should add up to 180 degrees. So if we subtract 95, we get that the measure of angle Y is 85 degrees. So that's how you can use theorem 10.9. All right, your homework 12 through 30 evens, that's on page 727. So we get to go ahead and do that again. So that'll be due. This is the DLD assignment. Of course, we're going to want it done before the test. But the due date here I'll post in the DLD module. So just have a wonderful afternoon.